So this is a question from the homework assignment for section 4.6.4, and we're going to use calculus to graph this function. Now in Newton, this is a multiple choice question, so it's a little bit easier because you can kind of match things up once you do just a little bit, but I'm going to graph the whole thing. Honestly, in today's age of technology, if we were doing this in class, I would probably show you more techniques of how this can aid in looking at a graph on your graphing calculator, since we could obviously just throw this in our graphing calculator. But so I'm going to go through all the old-fashioned steps for graphing this. So let's start with x-intercepts, or x and y-intercepts. So remember that an x-intercept is where the function equals 0. So if I set f of x equal to 0, I'll find the x-intercept. So I got x squared over 1 minus x equal to 0. A fraction equals 0 where the numerator equals 0. So if we set this equal to 0, we get 0. That means that y was also equal to 0 because we set y equal to 0, which means that we found both the x and the y-intercept. So we know that this graph crosses the origin, and that there aren't any other places where it crosses on the x or y-axis. We also know from looking at the denominator that it's got a vertical asymptote where the denominator equals 0. So if we set this equal to 0, we know we have a vertical asymptote at x equals 1. Looking at, for a horizontal asymptote, the degree of the numerator is greater than the degree of the denominator. So we don't have a horizontal asymptote. We do have a slant asymptote. So we can find the slant asymptote by doing long division with this problem. So I'm going to write this as negative x plus 1. So we're going to take and put that into x squared plus 0x plus 0. So I'm going to get negative x. This will give me x squared minus x. Hopefully you kind of remember this from pre-calculus. Distribute the negative. We'll get x plus 0. And we get a minus 1, a negative x minus 1. Positive x. Positive x minus 1. Now we switch our signs and we get a remainder of 1. But with a slant asymptote, you throw out your remainder, so we have a slant asymptote of y equal to negative x minus 1. So that's all the information before we get to calculus. Now we can find relative maxes and mins and where the function is increasing and decreasing by finding the derivative, setting it equal to 0, and doing the first derivative test. So we'll find f prime of x, and I'm going to use the quotient rule. So we're taking the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. And this will give us, 2x minus 2x squared plus x squared all over 1 minus x squared. And cleaning this up, giving us 2x minus x squared all over 1 minus x squared. So I can factor out an x here, giving us 2 minus x over 1 minus x squared. So that's the derivative. I can find the critical values by setting this derivative equal to 0. Again, a fraction equals 0 where the numerator equals 0. So the critical values are going to be at x equal to 0 and 2. And so then I can do the first derivative test by doing a sign test here. So if I choose a number smaller than 0, so I'm substituting this in right here. So say I choose -1. I'm going to have a negative, so I have, I wish you could see what I was pointing at. So I'm going to have a negative times positive, and the denominator is squared, so it's always positive. So this is going to give me negative values. So I know my function is decreasing from -infinity to 0. If I choose +1, I'll have a positive number in the numerator. I'll have a positive number times a positive number, and again the denominator is squared, so everything's positive. And if I choose a number bigger than 2, I'll have a positive number times a negative number, because 2 minus a number bigger than 2 will be negative. And again, the denominator is always positive. So I get that. So I know that I'm going to have, let's see, if we are decreasing and then increasing, I have a relative min at x equal to 0. And if I'm increasing and then decreasing, I have a relative max at x equal to 2. Okay, so now I need to do the second derivative. And I am going to label this because I'm going to take this right here and move it over to the next page. I'm going to take that one because the next one I factored it out and I don't want to do the quotient rule and the product rule. So let's bring this over here. So now using this, let's find the second derivative. Oops, there we go. So again, I'm going to take the bottom times the derivative of the top minus the top times the derivative of the bottom. I'm going to have to use a chain rule here. All over the bottom squared. I know this looks a mess right now, but, oops, squared. I didn't square the bottom. This is to the 4th power. But notice that in every factor here I have a 1 minus x. Let me clean this up a little bit so it's a little bit easier to see. So in this first one, if I pull out a 2 from the 1 binomial, I have a 2, 1 minus x squared times 1 minus x. And then in the second one, I've got 2 negatives giving me a positive. I have that 2. I'm going to pull out the x in this binomial, giving me a 2 minus x. I still have the 1 minus x. And then I have this over 1 minus x to the 4th. So every term has a 1 minus x in it, so I can cancel that out. I can cancel this one and this one, like I factored that out in front and canceled it with one of these, leaving me with this. So we're trying to set this equal to 0. I'm going to FOIL out the numerator and hope some things cancel here. So I'll have 1 minus 2x plus x squared plus 4x minus 2x squared. If I distribute that 2, I will have 2 minus 4x plus 2x squared plus 4x minus 2x squared. And then you can see that I've got a bunch of things that cancel out. So the 4x's cancel and the 2x squared cancel, leaving me with a second derivative of 2 over 1 minus x cubed. So our inflection point, or our possible inflection point, is where this either equals 0 or is undefined. Well, the numerator is never going to equal 0, so let's look at where this is undefined. This function is undefined at x equals 1. So x equals 1 is our possible inflection point. So if we do another sign analysis for x equals 1, looking at the second derivative, if I substitute in a number smaller than 1, like 0, I will get a positive value. And if I put in a number bigger than 1, like 2, in that denominator, 1 minus 2 is a negative 1, and a negative number cubed is still negative. So this is going to give me a negative value. So 1 is an inflection point. So it looks like everything before 1, from negative infinity to 1, is concave up, and everything from 1 to positive infinity is concave down. So putting this all together, and I know some of it's on the other page, I had a vertical asymptote at x equal to 1. I had a slant asymptote at negative x minus 1, which is like that. I had a intercept at 0, 0. I know that this function, looking over here, so looking back at down here, I had a relative minimum at 0 and a relative maximum at 2, and so I have a relative minimum at 0 and a relative maximum at 2, and I know that this is concave up from negative infinity to 1, so this is going to look like concave up with a relative minimum, and then right here, I'm kind of down here, this is going to be concave down, and there's my max right there. So there's the graph.